We have been configuring the basic routing and setup of the environment. Now we will take a closer look at the threat feature of secure firewall. Network discovery builds the FMC host database based on passive traffic analysis. The network discovery policy defines networks the system uses to collect this host, user, and application data and should correspond to internal or protected network. These lab tasks in the lab will get to first task. We'll add a rule to discover the hosts, user application for IPv4 19 IFC 1918. That's corp LAN and branch LAN networks. The second task will deploy a policy change and will find new hosts detected in the FMC host database. Okay, so let's do the first task, add discovery rules. In FMC2 web GUI, navigate to the policies. Go ahead to policies, network discovery. We said there was existing app IDs here for discovery. We're going to add a new rule. The new rule to the policy network discovery rules are unordered, so the position within policy does not matter. So we will add our internal lab range as well as IFC 1918 IP ranges from the available network here. We're gonna to add IPv4 private or IFC 1918 and branch LAN. The rule action should be discovered. Let's still proceed, and we're gonna go ahead. Should be discover, and we're gonna to check host and user. Let's click save. So my discovery policy should look like this one. We are then go ahead, so we'll make go to analysis, and we'll navigate to hosts and the network map. Notice unique host 0. No hosts in the database yet. Let's click deploy. In the top menu and deploy change to NGFW. So once the deployment is finished, we're gonna refresh the host screen. Let's refresh the page. We need to do one more thing. Add a rule. We need to add the corp LAN also. Save that. Deploy one more time. I should see these numbers that start increasing. Each page will refresh as hosts are passively added to the database. We're going to view the host entry, expand the tree on the left, and click one of the discovered the addresses. Host counts and accuracy will increase over time as the system processes more traffic. Next lab, we'll do the Mod1 file policies. In this lab, we will create the Mod1 and the file policy to be used later with access control rules. We'll configure the policy to block Mod1 files as well as blocking executable files from being downloaded via HTTP. This will also work for HTTPS if we implement TLS decryption. So two tasks. One is to block. We're gonna block malware for all supported protocols and file types, and we're gonna block download is MS exec file from HTTP. Let's do the first task. We're going to go policies. Policies will find a Mod1 file. We're going to create a new policy. It's called new file policy. The name we're going to do is block malware and save it. In this file policy, we're going to add a rule. The rule we're going to define is change the action to block malware and enable all the options for what we say super analysis for MSEXE, dynamic analysis, capacity handling, local malware analysis, reset connection for sure. Let's check the boxes against file categories, which will select all file categories. Okay, and click all types of or selected categories in the file type. I'm gonna click add. We could have selected all file types and added them that way. However, if the file type is added in later release, it will not be selected. So by selecting the file type category, any new future file types will be also included. Okay, let's save it. Now we're showing a file rule notification window. This is letting you know the dynamic analysis and the local malware analysis options only work on specific file types. Because my rule matches to all file types, those actions may not apply to all files. Now we will create a rule to block download of executable file for via HTTP. Let's add a new rule. This rule application protocol we're gonna select is HTTP, and direction of transfer we're gonna pick is download. Action we want to block file. We're gonna check reset connection for sure. Under file type category, we're gonna check executable. Executables. And file type we want to take MSEXE and click add button. Add a button. So you should see what we have right now. Click save to save the rule. So notice like we have some warning icons on by our rules. So the warning one indicates like the list rule will block malware lookups, right? We're gonna block malwares. Malware lookups won't occur on MSX file because the rule marked with warning one will block this file. The second, we're saying this rule will block malware lookups on MSX file for rule marked with warning 2. So this is because where the malware file rules are unordered, a block rule takes precedence over the rule to alert or inspector files. In this case, a warning is true if the file is transferred via HTTP. However, the file first rule will match any supported protocol, so the statement is only partially true. exe files transfers via other protocols will still be inspected. As long as we understand the behavior, there's no reason to take action on the warning. So let's click save to save the policy. So go to next lab we're gonna do is decryption policy. So in this lab we'll configure decryption policy. When it comes to decrypting TLS traffic, certificate management is one of the biggest challenges. So for inbound decryption, we use internal web servers that secret key to decrypt traffic destined there. So for outbound decryption, the device will resign TLS session with a certificate trusted by the browser. The trust is critical to the implementation of outbound decryption. Normally, there's already a public key infrastructure, the PKI, in the organization, and all of the workstations have common certificates authority, CA, that they trust. So the FMC will then import the CA certificates and use it to re-sign the outbound communications. So this trust is important to avoid browser errors and messages to take effect that the communication is not secure. So for our lab, we'll use internally generated CA to re-sign the outbound connections. This will not be acceptable in normal environment. However, our focus here is on the FM policy, not how to build and maintain a PKI. So we'll do a few things in this lab. The lab one we're gonna do is we're gonna generate the internal CA and on FMC, and we're gonna use to re-sign outbound decrypted traffic. The second, we're gonna create a new decryption policy, named decrypt outbound, and we're gonna add a rule to decrypt traffic from the lab networks to internet using generated CA certificate. And we're gonna create a rule to block insecure SSL v3 and the TLS10 protocol. Okay, and we're gonna create do not encrypt rule. We're gonna do not decrypt, sorry, decrypt rule for the sum of the traffic. So first, the traffic we're gonna do is a financial traffic. We don't want to leak anything of that financial traffic, and we're gonna healthcare traffic and applications that ping the certificates, and we have a ping cert, and I will cite Cisco on the decryptable sites. object group. Also, Spotify.com, Plex.tv, those things we don't want to block, decrypt. So let's first generate MC internal CA. In the FMC2, we're gonna to go object and object management. We're gonna to expand PKI. Click internal CA and click generate CA button to create a new internal CA. This is gonna be called Cisco Lab, country name US, California, San Jose, Cisco systems, infosec. And when finished, we're gonna click generate self-signed CA. So then task 2, like I said, we're going to create decryption policy. Still go to policies and decryption. I'm going to create decryption policy. The name here, we're going to say decrypt outbound. And we're gonna click CA, internal CA, Cisco Lab, okay. And the drop down, we're gonna select this, okay. And click no network port associated. Click, okay. We're gonna to limit the rule for outbound traffic only. For source network, we're gonna select lab networks. Lab networks. And in the destination, we're gonna make destination network for ports here. Destination, we're gonna select HTTPS. Okay, like this, we're gonna to click apply. This will automatically create an all-bound decryption rule in our policy. So let's click see how to configure. And this link will for some information on how to download, search, and distribute it to your users. So let's click save. Let's click the pencil icon to the right to open the policy decrypt while bound for editing. The automatic creator rule will decrypt all traffic originating from Cisco lab network. However, it will decrypt traffic within the lab network as well. We need to limit a rule to only decrypt traffic going to the internet. So that's click the pencil by the auto-generated rule named Cisco Lab rule. Yes, Cisco Lab rule. And the name is gonna be changed. We're gonna change to decrypt outbound. And zones, we want to add zones. Zones, we want to use out zone to destination, and we're gonna click logging. We're gonna log at the end of connection. Click save, So reposition the rule into the rule categories by clicking the drag and clicking the drag. So how do I do that? Yeah, try to do this way. Yes. So now we have our decryption rule. The deported policy would decrypt all traffic, all bounds from the lab networks. Now we will add some additional rules to deal with conditions where we might want to block or avoid decryption traffic. So first we will add a rule to block older insecure SSL or TLS versions. So let's click add a new rule. The rule here, we're gonna to name it as block insecure versions and insert into standard rule category. Okay. The action will be block with reset. Click version tab. In here, we want to check only SSL 30 and TLS 10. Add a logging. Check log at end of a connection. And add a rule. Now we did not configure any source destination conditions, so this rule will block all insecure SSL/TLS traffic regardless of source or destination. Decryption and exceptions. The bulk of the rules within decryption policy will consist of decryption exceptions. So next we will add a rule to prevent decryption of sensitive traffic. We're gonna create a do not decrypt rule to match traffic to trusted banking healthcare site and name the rule as DND banking and health. So let's do it. We're gonna to say the name is gonna be DND do not decrypt banking and health. We're gonna insert place into the category standard rule below the first rule, right? And source network will be the lab network. Destination is not destination network, it will be destination zone, alt zone, and we'll click the category. In category, we're gonna search about finance here, add to finance, and we're gonna health care and health and medicine. So any trust, okay. I'm gonna log at the end of the connection, add to it. All right, So add a rule will provide a decryption exception for traffic from applications that are known to use append certificates and are therefore undecryptable. So let's create another rule. It's gonna be do not, well, how do I do it? Do not decrypt do not decrypt pinged apps applies to the standard. So the order isn't important as long as it comes before decryption all-bound rule. So we're gonna configure zone network to zone. We're gonna still go to network, lab network. From lab network, click application filter. We're gonna match is the pin certificate. That's added rule. Gonna also log at the end connection. So the last rule will provide a decryption exception for connection using specific distinguished name DN in the certificate. We will start with the included system object, which has the number of known decryptable sites, and add a couple of so let's create do not decrypt rule. Do not decrypt specific DNs. Also gonna insert to standard. So it all comes before decrypt all bound. And we're gonna create the zones, network. We're gonna match from lab network. We're gonna click DN tab. Let's locate Cisco on decryptable sites. Add to the subject DM. And we'll let log at the end the connection. So these are two ways we can add customer DN to this rule. One is to add the object, then use it in the rule. The other way is to enter DN directly into the rule. The first option usually preferred in case the object needs to be used elsewhere as well. We'll do one of each. Let's click DN. We're going to add a DN name. DN, we want to say Spotify.com. Click Save. Spotify.com. Next, we want to add is the Plex. It's gonna be cn equals plex.tv. plex.tv. Add it. We're gonna say so we don't need a name, like just do this like this. Okay. Plex.tv. Okay. Let's add a button to save the loop. So we have created decryption policy with a few standard exceptions for decryptable sites. In actual production deployment, this would be just a start with the other DND exceptions added later as policy is tested with the actual traffic. Let's click Save. One next thing we'll do is intrusion policy. So a key component of the system is deep packet inspection. This is a preferred device node and is configured via intrusion policy. So we will create intrusion and network analysis policies to be used in our deployment. The both of these policies configure the snore deletion engine. The intrusion policy is focused on the snore loop set to where network analysis policy is used to configure advanced options. This time we're gonna create a prevention. Create a prevention mode IPS based on a balanced rule set, and we're gonna create a browser to Firefox rule group to use security level 3, and we're going to disable SID 52431 in the policy, and we're going to run Cisco recommended rules based on security level 3, and do not disable any rules. And next, we're gonna create a network analysis policy. We're gonna base on a balanced policy. Okay. So let's create an intrusion policy. Policy here, we're gonna go ahead create is intrusion. I'll create a policy. It's called a balanced intrusion. Inspect modes, we're gonna make is prevention, and base policy we're gonna based on the balanced, secure, and connectivity. Save. The new policy using a balanced security and connectivity rule set is an excellent starting point for most organizations. The system has created two policies, one for Snore 2 and one for Snore 3. So these policies are independent, and any changes made to one will not impact the other. Because we have only Snore 3 deployed, we will only be working with this version of the policy. First, the policy is a copy of system provided rule set, but as the traffic is inspected, there may be a need to adjust the rule set based on specific organization needs or false positive detections. In our case, we would like to adjust the rules for our corporate standard browser by increasing the protection level. So let's click the SNOR 3 version. The initial view is the summary tab. Here you can see the various layers like a base, a group overrides, recommendations, rule overrides. Currently the selected summary tab is summary of the rule states based on the layers. So let's click a layer allows you to view or edit the layer setting. So let's modify rule group security level. Now we will increase protection level for our corporate browser. Let's click group override layer. Let's expand rule categories. And we're gonna expand the browser category. Within the browser category, there are 6 groups corresponding to various web browser types. We'll notice that the blue security level icon is the right of each group, showing each group is using security level 2. This corresponds to the balanced security and connectivity rule sets and is security level inherited for all groups in this policy. So in the edit security level, we can change the security level and change the rule set that a Firefox rule group uses. The number of alerts and block rules currently enabled in the policy. Okay. So I click the security level and I'm going to increase, and non-like description we're going to change, showing is the higher level. Let's click save, and Firefox group now has customized security level and the icon showing the group has been overwritten. The Firefox rule group now has additional rules enabled based on the security level 3. A new rule updates that are applied. This group will continue to use most up-to-date rules based on this new security level. And you notice the number of active rules has now changed also. Let's disable SNOR 3 rule, where the above steps is preferred when making adjustments to my intrusion rule sets. We can also override rule states specific rules. So a common reason for this is to disable rules that are causing false positive alerts. Let's click summary, and I may see a rule list. If I see summary page, click view effective policy. So the page shows me effective policy as a result of the layers. Each higher layers can override the rule states set in a lower layer. The order of priority from high to low is like the rule overrides, recommendations, and rule group overrides, base policy. So we will override a specific rule. The action will take effect at a rule override layer. This means regardless of how the rule state is set at a base policy group overrides recommendation layers. Whatever we set the rule overrides layer will prevail. So from the summary page, we can scroll through the rule set. However, because of the large size, this is not a practical way to find a rule. The search bar at the top of the list provides a server way to locate a rule. So this can be done by generator ID, node ID, as well as a free form search of the entire rule. User can also search for rules written for specific common vulnerabilities and exposure CVE identification number. We're gonna click advanced filter and give more options, including search for rule for a specific lightweight security packet LSP. Release. Users can also search for just a new or updated rule in given LSP. So in our case, we know specific rule ID as known as the specific identifier or SID. So click the search field. We're gonna enter what we want is the five two four three one and press enter. Now the server rules were returned as the system searched all rule data for search term. The rule we wanted is at the top of the list. We could have been more specific by typing SID colon 52431 in search. This would have returned just a single rule, right? Let's expand, clicking the symbol to the left. So I can see the rule content and what it is searching for. We now need to disable this rule as it is generating false positive alerts. So I want to click the drop down under rule action column and we're gonna make it disable. So this change is overwritten to the policy immediately. And I can type of comments why I disable, right? Disable due to false positive. Add comment. Save. Cisco recommends rules. So the system can help automate the policy turning process by making recommendations on the rules to enable or disable. So this feature is called Cisco recommended rules. It is based on information in FMC host database. We'll configure a system to enable additional rules based on the vulnerabilities possibly presented in the environment. We're gonna click recommendations layer. We're gonna note that this currently states that recommendations are not in use. So next dialog is the Cisco recommendation rule configuration page. We're going to click start. So security level, this determines the rule sets that will be used to recommend changes to my policy. So they correspond to various base policy rule sets. So recommendation will not select from enable rules in selected security level. That means if my base policy is security level 2, which is balanced, we're gonna select the security level 2 here. We'll never enable additional rules. This only way to enable additional rules is to select the security level higher than that of the base policy. And we're gonna what is accept? what does accept the recommendation to disable rules? So the system can enable rules based on vulnerability. Based on the vulnerabilities in the host database, it can also disable rules based on the absence of vulnerability. So checking this box enables system to automatically disable rules written for vulnerabilities and that were not detected on the network. And also here, protect the network. So this is obviously the network range that will be used to filter the hosts that are available in the host database. So if I only wanted to base recommendations to on our subnet or for host in the database, we're going to use network object here to restrict the hosts. So we're going to click the bar security level to 3. Since we are using a larger rule set for recommendations and have not checked the disable rule box, this will result in additional active rules. So again, we're gonna see active rule count in our policy up right here, right corner. We're gonna click generate and apply. So now we see increase the count of active rules, and my policy layers now show that recommendations is active. Next we'll do is network analysis policy. We're gonna to return the policy intrusion policy list. We'll go to policy and intrusion. There's no need to save the policy as all policies are written immediately. We're gonna click network analysis policy. We're gonna create a policy for analysis. The name we're gonna say lab balance the NAP, network analysis policy. The base policy, we're gonna select the secure balance secure connectivity. Click save. So as with the intrusion policy, there are Snore 2 and Snore 3 version. So we're gonna click Snore 3 version. You're gonna give it a warning. Network analysis policy customization should only be performed by advanced user, always advice of Cisco TAC. So the various inspector configuration list here, data is shown in JSON format. We're going to use various items on the action button. To the right, user can view, download, upload network analysis configurations.
Hey everyone, NetMaven here. Don't forget to hit that subscribe button to dive into the world of amazing network technologies with me, and please feel free to leave your comments below. Hey everyone, NetMaven here. Don't forget to hit that subscribe button to dive into the world of amazing network technologies with me, and please feel free to leave your comments below.